Okay, good. Now let's continue our good work. Now we want to look at radical numbers. Radical numbers are also called surd. Okay, it's also called surd. So radical expression, radical number. And we're going to look at square roots. That is the first radical we know, and then a lot of them. But our target will be on the law, the simplification, the conjugates, and rationalization. Let's begin. So radical, of course, it's not new. Remember. So if we have A here, we have B here. This A is called the index or power, but it's going to be fractional power. This B is called the radical. Radical. Of course, this is called square root, or you call it radical symbol. And all this together is called the radical number. It's the index, this is the radical, this is the symbols, that is square root or square, and all of them is called radical number. This is very important. So if you say square, roots, that is, he said the roots of something. So square root means that this guy is standard 2, okay, but we don't use to write it there. So if I say root 25, that is square root of 25, which is what? 5, the standard form. Sometimes it's not standard. Remember, under the rational number, if you have, let's say we have 12, for example. 12 is not a perfect square root, but we can split it into 3 times 4, right? We have done something like this, remember? Just try to recall. So this guy is the same thing as root 3 times root 4. That is square root, because we don't write anything. And this means what? What is square root of 2? 4 is 2. This is not standard. So we can write 2 root 3. We have cube root. Cube root means this letter will be 3. Okay? This letter will be 3. Just like this one, that it is 2. But if it's 2, we don't need to write it. But if it's 3, 4, 5, and so on, we must write it there. It is a must. So, let's say we have the cube root of 27. This cube root of 27 means the number to multiply 3 times that will give us 27. And obviously, it's what? 3. Right? So this is like cube root of 3 power of 3. So this guy, take care of this guy, and the answer is 3. Okay? This is just a quick revision because we have done something like this, if you remember. So just to refresh our memory. So our target now is the rules, the actions, the procedure, the law of radical. Let's begin. Now, the laws of radical. Let's start quickly. The first law, or the first rule. 1, I call it addition rule. Addition. Why did I call it addition rule? You have the roots of A plus the roots of B. They are not in the same roots, right? So the answer remains same. But if you have the roots of A plus 2, the roots of 2 root of B, this is 1 here, right? This is square root, this is square root. So since square root is common, I choose 1. So that is 1 plus 2, which is 3. Root A is common. I pick 1, root A. Okay? This is very important. What of if we have the fourth root of 7 plus the fourth root of 3? Can it work? No. This is fourth root, we know, but this is 7. This is fourth root, we know, but this is 3. They are not common. So the answer remains unchanged. Okay? So this is very important. These roots must be the same, and the index should be the same, which is the same, and the radical number inside must be the same. If it's not the same, addition cannot work. The same thing with subtraction. Subtraction rule. Say root A minus root B. They are not in the same radical, so it remains unchanged. But if you have root 7, that's 3, root 7 minus 2, root 7. The index is the same, which is 2. The radical is the same, so you pick 1. So you have 3 minus 2, that is the whole number, and then root 7, you pick 1. Just like what we did in logarithm. Other logarithm, if you have the same log, you pick 1. Other indices, if you have the same base, you pick 1. Right? The same thing, if you have the same root, you pick 1. So you see, indices, logarithm, and surd, they work pari passu. So this is what? 3 minus 2 is what? 1. So I can just write root 7. What if I mix together? Maybe I say 7 third roots of 2 plus 3 third roots of 2 minus 4 third roots of 2. Now let's check the index first. The index or the exponent is what? 3. 3. 3. That is 1. They are the same. The root of 2 is common. So which means I can choose only 1. So I just write the number here is 7 plus 3 minus 4. Everything in third root of 3. Are we together? If this guy is not the same index and it's not the same radical, you cannot put them together. Please take very good note of this. So now I can say 7 plus 3 minus 4, that is 7, 10 minus 4, 6. That is 6 third roots of 2. This is like 2 times the third root of 2. Please take note of this. Now let's go to multiplication rule. Let's call this one with 3. Multiplication, or call it product rule. Product rule. At least you say root A times root B. Now, this one, if it's addition and subtraction, you cannot do anything. But multiplication, you can do something. The only law you have to consider here is that are they having the same index? The index here is 2. The index here is 2. Yes. What is inside the bracket is not the problem. Since the index is the same, you just take only one index, that is A times B. So this is what? Root A B, because they are the same index. If they are not the same index, you cannot operate it. Addition and subtraction, it must be the same index and the same radical. If it's not, no. So this is very important. Let's do an example. Let's say we have root 2 times root 3. This is what? Root 2 times 3, which is root 6. Right? Clear. What if you have third roots of 7 times 2 times third roots of 3? We have to be careful here. This Third root is inside. It's called index. There's no number here. The index here is 3. The index here is 3. It's the same, which means we can put them together. This place is 1. So 1 times 2 is the whole number. The index is 2, so I can just take only one index, which is 3. So multiply inside 7 times 3. Please be careful here. We have whole number, index, and radical. So here, 2 times 3 is what? 2. Third root of 21. Be careful. These are two different things. This is outside, this is inside the bracket. Okay? The fourth root is quotient rule, like division. That is, if you have root A divided by root B, the same law happens here. If they are the same index, you choose only one. So that's root A over B. Root A over B. Example. If you have root 4 divided by, let me say, okay, root 4 divided by root 2. They are in the same root, right? Choose one. You have 4 by 2. 4 by 2 is what? 2. That is square root of 2. Right? Here's another example. Let's say we have this time around, we have okay, root 3 times root 5 divided by root 6. Root. They are the same root. So we can put them in only one root. So we have square root of all of them. Why? Because they are common. Index is 2, index is 2. If they don't write anything, it means that index is 2. The lowest index you can see in the square is in a root is square 2. So index is here is 2. If they don't write anything there. If it's 3, we will write it there. If it's 4, we will write it there. If it's 5, we will write it. If it's 7, we will write it. 100, we will write it there. But root 2, they will not write it there. Usually we don't even write it there. So root 2, I can write 3 times 5 divided by 6. Right? So I can take my scissors and try to cancel some things. So 3 goes here, 1, 3 goes here, 2. What is left? We have root 5 over 2. And this is finished. Root 5 over 2. Now, sometimes, and this is where I am going, sometimes this one is easy because root is up, root is down. This one is only one root. This one root is up, root is down. But sometimes, if root is down, there is no root up. We have to do what is called rationalization. We have to rationalize. What do I mean? Good. So, the fifth rule, I call it rationalization. Rationalization. When you are rationalizing, don't forget, you are rationalizing the denominator. Let's use this, for example, this guy. We say root A divided by root B. So let us remove root from here. This is the same thing as A over root of B, right? In mathematics, we don't like to give our answer this way. We don't like to put radical in denominator. So what we do? We rationalize denominator. How do you rationalize? It's just like a little manipulation. We have A over root A. What you have to do is multiply the numerator by denominator and multiply denominator by denominator. What am I saying? If you cancel this guy, it still is. Right? Because I don't want the root to be here. So multiply it twice and multiply the denominator. So a times root a is what? A times root b is what? A root b. Because this is 1, right? 1 times a is whole number. This is radical number. They are not the same. You don't put them together. If this is root, you can put them one. Like this one. Root b times root b is what? B. R. Root b squared. This is 2, right? The 2 cancel the denominator and we have only b left. Remember, I explained something like this before. So now, what we did here is called rationalization. We have rationalized the denominator. Let's do an example. Let's say we have 3 root 2. In math, we don't agree with this. We have to rationalize. So if you say rationalize this, that is 3 over root 2 times root 2 times divided by root 2. Okay? So we have 3 root 2 divided by root 2 times root 2, that is root 4. And root 4 is what? 2. And now we can write 3 over 2 root 2. This is called rationalization of denominator. We break it down. The last rule I want to teach you is conjugates. Rule 6. Conjugates. You also rationalize, but this time around you rationalize of course, the same thing, denominator, but there's something changed. Let me show you. The conjugate of a plus root b is a minus b. The conjugate of a plus root b is a minus. When you find a conjugate, you find the opposite side of the. If it's plus, it becomes minus. If it's minus, it becomes plus. It's very important. So let's assume we have example. Can you see? Simplify 2 divided by 1 plus root 3. Don't forget, this one now cannot work here because we have 2 numbers. So we have to rationalize, yes, but we have to rationalize with conjugates. This is very important. When you get to read calculus, especially under limit of calculus, we need this. Take notes. Take notes. Okay? So what do? To find this guy, we have to rationalize the conjugate. So we have 2 divided by 1 plus root 3 times, don't forget, we have to multiply this guy, but now we have to find its conjugate. Conjugate of 1 plus root 3 is what? 1 minus root 3. And right again, 1 minus root 3. You see, it's the same. But this place is only one side. But this place we can have sort, we can have whole number sort, we can have sort whole number, doesn't matter. Once it's combined of 2 operations or 2 numbers together, you need to find the conjugate. So easy, we can multiply now. So this is what? 2 times 1 root 3 divided by 1 plus root 3 times 1 minus root 3. It's the same thing, I just repeat it. It's really easy for me. Now I can multiply. 2 times 1, open bracket. 2. 2 times, this is minus, right? So minus. 2 times root 3. This 2, you don't have root. It's outside. This 3 is having root. So it's like you are multiplying 2 times 1 root 3. So we have 2 root 3. Please be careful. This is not root. If it's root, you put them together. So this is 1 root, 1 no have root. divided by, now, down. Open the bracket. 1 times 1, 1. 1 times minus root 3, minus root 3. Root 3 times 1, plus root 3, plus times minus is minus. Root 3 times root 3 is what? 3. Root 3 times root 3 is what? Root 9. And root 9 is what? 3. By the way, when you are multiplying the conjugates of its number, of a number, this must surely cancel. So, if you like, you may not write it there when you are calculating. Because conjugate of itself will cancel. So, we now have what? 2 minus 2 root 3 divided by what is left here is 1. What is left here is minus 3. So, this will give us 2 root 3 divided by minus 2. If you like, you can stop here. If you like, you can separate it. You can say 2 by minus 2 root 3 minus 2. 2 cancel 2. What is left is minus 1. Minus minus plus 2 cancel 2, 1. So the answer is minus 1 plus root 3. This is rationalization, and this is rationalization of a conjugate. Please be careful with this too. It's very important. It's very, very important. I will just have one more example, and that should be enough for radical number. Now, this is very nice example. Very, very nice example. Let us take this minus. Now, first, we have very big numbers here. Before we can rationalize, we need to simplify first. Simplify this guy, simplify this guy, simplify this guy, simplify this guy, and put them together back. This is the best way to make life easy for everybody here. Okay? The first one is 72. Let me write the solution. 72 simplification. We have to think of two numbers. One perfect root, one without perfect root. If all of them perfect roots, it's super. So what can we make to the perfect root? Let's see. 72. 2 can go, right? 2 goes in 7, 3. 36. So 36 is perfect root. So we can say 2 times 36. Right? Which means root 2 times root 36. Root 36 is what? 6. So we have 6 root 2. The first one is simplified as 6 root 2. Good. What about the second one? Squared of another squared, 2, 5, 6. If nothing is written, I told you it's 2, right? You agree with me? Good. Now, what is the square root of 2, 5, 6? That is 16 times 16, right? 16 times 16 will give us this one. So the root will be 16. So we have 16. So one root has been taken care of. Again, root of another root. Root 16 is what? 4. You have to be careful here. It's 2 roots. First, the first one is this. Root of this is 16, and the second root, which is 4. So this guy is this guy, this guy is this guy. Let's go to the second one, the third one. The roots of 0.04. First, change it. You can change it, right? This is the same thing as the root of 4 over 100. Right? You agree? This is changing decimal to fraction. It's very important. We have done it before. Check our previous video, you will see it there. So what is perfect root of 4? Is 2. What is the root of 100? Is 10. This is easy. This is easy. 2 goes here, 1, 2 goes here, 5. So this guy is this guy. The last but not the least, root 12. Root 12 can be read as 3 times 4, which means root 3 times root 4. Root 4 is 2. So we have 2 root 3. So this guy replaces the original, this guy replaces the original, this guy replaces the original, this guy replaces the original. What do you now have? This guy is what? 6 root 2 minus. This guy is what? 4 divided by. This guy is what? 1 over 5. And lastly, this is 2 root 3. Is this final answer? This is plus, or this is plus. Is it final answer? No. It is now we have to start the the conjugate of rationalization, which means times half 1 over 5 plus the conjugate 2 root 3 divided by 1 over 5 plus 2 root 3. This is the conjugate of this guy. Plus minus become plus. Now open the bracketed. We have 6 root 2 plus 4, 1 over 5 plus 2 root 3, 1 over 5 minus 2 root 3, 1 over 5 plus 2 root 3. I told you, if you multiply the conjugate, all the surd, all the radical number will go. I've told you. Now let's just multiply this one. 6 times 1 over 5. That is 6 over 5 root 2. This guy, this will be 6 times 2, 12. Root 2 times root 3, root 6. Right? Now come here. 4 times 1 over 5, 4 over 5. 4 times 2 root 3. That is 8 root 3. This is for the numerator. There's nothing you can do. We have to leave it like that because this is already 2. There's nothing to divide it. This is already 2. There's 6. There is no perfect root. This is already 3. There's no perfect root. So down. 1 over 5 times 1 over 5. That is 1 over 25. Look, this guy will cancel this guy. If you don't believe me, let us write it out. We have this and this. That is 2 over 5 root 3. This and this minus 2 over 5 root 3. What do you notice? It must cancel. So if you like, you may not write it down. If you like, you may not write it down. Since you are sure. Because you are doubting me, that's why I try to write it out for you. Now this is minus plus is minus. 2 times 2 is 4. Root 3 times root 3 is root 9, which is what? 3. But let's write it out. Root 9. Right? For the whole, write it like that. There's something you can do for the numerator. That is 6 over 5 root 2 plus 12 root 6 plus 4 over 5 plus 8 root 3 divided by, this one is gone. So this is 1 over 25. This is 2. This is 6. Sorry. 4 root 3. Root 9 is 3. 3 times 4 is 12 minus 12. Do you see solving? Do you see radical number again? No. If you stop here, you will not get full point because radical should not be in the root. So this is fraction. You remember fraction? 1 over 25 minus 12 over 1. Common factor is 25. 1. This is 1. This is 25 times 12. This is 0, 5, 5, 2. That is 300. Right? Yes. This and this 10, 1. This and this 4, 5. Then this 5. This and this. That is 300. So this is like 6, 5, root 2, 12, root 6, 4, 5 plus 8 root 3 will now give us what? Minus 299 by 5. If you stop here, it's okay, but I don't like it. You can let this guy go up, right? To make it look nicer. If this guy go up, this 5 go up, this minus can also go up if you want. Let's see if I go up. If I go up, the 5 will come and remove this guy. The 5 will multiply this guy. The 5 will remove this guy. And the 5 will multiply this. So what do we have? We have, if I go up here, it will cancel this 5. So we're going to have 6 here. Root 2. If this 5 go up here, we have 12 times 5 will give us 60. That will be 60 with 6. If this 5 go up here, it will cancel this 5. It will remain only 4. So we have 4. If this 5 go up here, we have 5 times 8. 5 times 8 will give us 40. 40 root 3. Everything over minus 299. You see, it's a little bit looking nicer. If you now want to finish it, you can just say this divided by this, then you have minus 6 over 299 root 2. It's finished. Plus, minus plus is minus. Minus 60 over 299 root 6. It's finished. This one minus 4 over 299 is finished. And this is minus 40 over 299 root 3. And that's looking nicer now. We have given them, each of them, their value.